All right, assalamu alaikum, everyone. Let's begin then. So today we're starting probability. This is the next topic that we're doing. It's a small one, so hopefully we will be able to cover most of the concepts of this topic today, and possibly do some practice questions as well, along with completing the concepts. Uh, we might be able to do conditional probability as well, which will complete this topic. But if not, we will do conditional probability in the next session if we are not left with enough time in this session. So let's begin then. What is probability, first of all? So this is something that we talk about in our daily life generally as well, when we talk about the chance of something happening. So if I were to say there is a 25% chance of raining today, this 25% is basically the probability of raining. Okay, so chance that we talk about generally is basically known as probability in mathematical language. Okay, so we can talk about probabilities in terms of percentages. That is one idea, but more commonly, what we do is we represent percentages. We represent probabilities as decimal values like this, or fractional values. So what's the equivalent of 25% in decimals? We can say that is 25 over 100. That's the fractional value, or 0.25 in decimal. We would say there's a 0.25 probability of it raining today, or 25 over 100, which means a 1 out of 4 chance of probability of raining today. Okay, so it's another word that we use for chance of something happening. Generally, we talk about percentages in our daily lives when we talk about chance, but in terms of probability, we mostly represent this chance as a decimal value or a fractional value. So you can represent it as a fraction like this or a decimal like this. Okay. Now, since generally in percentage form, if we say something has a 0% chance of happening, that means that this thing is impossible to happen. The lowest possible value that you can have for a percentage when we talk about chance, that is generally 0%. And then if you say something is absolutely certain to happen, you generally say there's 100% chance of that happening, right? So and that means that something is absolutely certain to happen. It'll definitely happen. When we convert these numbers to probability, 0% in fractional form or decimal form, it would still be 0. So we can say 0 in terms of probability means that something is impossible. There's a 0% chance of that happening. What about the equivalent decimal value or a numerical value for 100%? 100 divided by 100, that is 1. So 100% corresponds to 1 in probability terms. So probability is always some number between 0 and 1. Okay, mostly it's between 0 and 1. 0 means that something is impossible. 1 means that it is absolutely certain that it will definitely happen. But mostly the number is going to be between these two values. Okay, now in this topic we will basically be talking about how to calculate probabilities. The formula that we have for probability is written like this generally. Probability equals number of favorable outcomes divided by the number of total possible outcomes. Now, let's try to understand what this means. Number of favorable outcomes divided by the total number of possible outcomes. Let's understand this using an example. But this is this formula that we will be using everywhere whenever we are supposed to find probability of something. Let's take an example. Let's say You have a fair coin. Let's say you toss a fair coin. What's the probability? What's the probability of getting a head? So you have two sides of a coin, heads or tails. What's the probability that you would get a head? Now, when we talk about fair coin or fair dice, it's important to understand this terminology. Fair means each outcome has equal probability. Each outcome has equal probability. So in this case, when you're tossing a coin, you have two possible outcomes from that. You can have heads or you can have a tails, right? These are the two possible outcomes that we can have. If the coin is fair, that means the probability that you would get a head or the probability that you would get a tail, they have equal chances, right? They're equal probability of getting a head or a tail. The opposite of this is something that is biased. So sometimes you would have a biased coin or a biased dice as well. In that case, that would mean that the coin is not fair or the dice is not fair, which means each outcome does not have equal probability. So biased means it's not fair, right? So fair means each outcome has equal probability. Biased means each outcome does not have an equal probability. In this case, we're tossing a fair coin. If the coin is fair, that means probability of getting a heads and the probability of getting a tails is going to be equal. Now, how many total possible outcomes are there? Think about it. When we're tossing a coin, you can either have a heads or you can have a tails. The total possible outcomes are two. One is head and the other is tails. Okay, these are the two possible outcomes that you can have. Now, what's the probability that you would get a head? What does the formula say? Number of favorable outcomes. What does favorable mean? Favorable means the outcomes that satisfy your condition. So what's the condition in this case? The condition is that you should get a head. Okay. So probability of getting ahead, what would that be? That would be 1, because out of these two outcomes, one is head, divided by the total number of possible outcomes, that's 2. Probability of getting ahead in this case is going to be 1/2. And similarly, probability of getting a tail in this case is also going to be 1/2, because tail is 1 out of those two possible outcomes, right? So that's the simple formula of probability. What does favorable mean here? I'm going to write it down here as well for your notes. Favorable means the outcomes that satisfy the given condition. So, for example, if you're finding the probability of getting a heads, getting a tails, that means that your condition is that you should get a tails. So that's the favorable outcome, getting a tails. That's what you have in the numerator, and then in the denominator you have the total number, which in this case is 2. Okay, that was a fairly straightforward example. But now let's make it slightly more complicated. Instead of tossing one coin, let's say you're tossing 2 coins now. So let's say you toss 2 coins. So now what you're doing is you're saying, let's say you're tossing 2 fair coins. Again, fair means that the probabilities of heads and tails are equal. What's the probability of getting 2 tails? How can we find this probability now? Probability of getting 2 tails. Now let's list down all the possible outcomes that we can have. If you're tossing two coins, one possibility is the first time you toss a coin, you get a heads. The second time you toss a coin, you get heads again. So that's heads and heads, right? Another possibility is that the first time you toss the coin, you get a heads. The second time, you get a tails. Another possibility could be that you get tails the first time, heads the second time, and then you could get tails the first time and tails the second time. These are all the possible outcomes that you can have when you toss two fair coins. Okay. Now, how many outcomes are these in total? These are 4 outcomes in total. We want the probability of getting two tails. Probability of getting two tails, TT, or you can say two tails. That's 1 out of these 4 outcomes, right? So what would the probability be? The total outcomes are 4, right? These are 4 possible outcomes, out of which 1 is favorable. That is TT. That's your numerator. So the probability of getting two tails would be 1/2. Okay. Now, in this case, they might have something else as well. Let's say they want the probability that both outcomes are different. That when you toss two coins, the result that you get from both the coins, they are different. They're not the same. So if you get heads the first time, you should have a tails the second time. If you get tails the first time, you should get a heads the second time. The outcome should be different. 1 heads and 1 tails. Now, which ones out of these 4 cases satisfy this condition? Let's count them. It's the second case and the third case. In these 2 cases, the outcomes are different. Okay. So you say the number of favorable outcomes is 2, divided by the total number of possible outcomes, that is 4. So that's your probability. You can simplify this, and that gives you 1/2. So generally, if you have a probability in fractional form, you would prefer writing it in simplified form at the end. So it's 2/4, which simplifies to 1/2 at the end. Okay, so that's the final result. Now, this is one type of problem that you will see quite often when you have to toss some coins. Another thing that you will see being used a lot when you have probability questions is that you would be rolling dice. Okay, so you'll have a dice that you would roll, and that would have different possible outcomes as well. Let's consider that situation. So let's say now you roll a dice. Okay, you roll a dice. What's the probability? So let's specify here as well that it's a fair dice. Now, a dice has 6 sides, right? 1, 2, 3, 4, 5, 6. If it's a fair dice, what that means is each of those 6 possible outcomes have equal probability. Okay. 1, 2, 3, 4, 5, 6. Each outcome has the same probability. That's what fair means. Okay. What's the probability of getting, let's say, a factor of 12? What's the probability that you would get a factor of 12? Now, how do we think about this? What outcomes are possible? Let's list them down. 1, 2, 3, 4, 5, 6. These are the 6 possible outcomes that we have. Now, how many of these 6 outcomes are factors of 12? What are factors of 12? Is 1 a factor? Yes, 12 divided by 1. That gives you 12, an integer. So 1 is a factor. 2 is also a factor. 12 divided by 2 gives you 6. That's an integer number. 12 divided by 3 gives you 4. That's also an integer. 3 is also a factor. 4 is also a factor. 5 is not a factor because when you do 12 divided by 5, that gives you something in decimals. 6 is also a factor. So out of these 6 numbers, 1, 2, 3, 4, 6, 5 of them, they are factors of 12. So what is the probability going to be? This is the notation that we generally use for probability. P of, and then in the bracket, you have the outcome written. So if you're thinking about factors of 12, you can say probability of getting a factor of 12. Okay, so how do you understand this? This notation means probability of getting a factor of 12. What would this be? The total number of possible outcomes is 6. Out of them, how many are favorable outcomes? The outcomes that satisfy the condition, 5. So the probability, therefore, is 5/6. That's the probability that we were looking for. Okay. So this is how we can calculate probabilities in simple cases like this. Now, what if we change this slightly and now we say you're rolling a dice. Again, it's a fair dice. What's the probability of getting a number that is not a factor of 12? So you can say, what's the probability of not getting a factor of 12? How do we think about this now? Probability of not getting a factor of 12. The total probability is always going to be 1. Okay, the total probability of anything is always going to be 1. Right? So if you say, in this case, for instance, this example that we started from, we said there's a 25% chance of raining. Okay. Then there's a 75% chance of not raining. Right? If you add these two up, the total is always going to be 100%. In terms of probability, we can say the total probability of any particular event is always going to be 1. Right? So in this case, now that we know that the probability of getting a factor of 12, that is 5/6. What's the probability of not getting a factor of 12? One way to think about that would be that probability of getting a factor of 12 is 5/6. Not getting would just be the total probability, which is 1, minus 5/6, and that gives you 1/6. Okay. Of course, you could look at the outcomes again and look at the numbers that are not factors of 12. So that will be 5, and that's 1/6 probability. You could get that directly from there as well. But sometimes you have to use this idea that if you have one probability and then you're finding the probability of that not being the case, that not being true, we just can subtract that the first probability from 1 to get that result. Okay. In set notation, if you remember sets, if you have a set A, for instance, if the probability of a set A is 2/3, then probability of A complement, remember complement? Complement means everything that is outside of the set A. What would that be? That would be 1 minus 2/3, and that's 1/3. So sometimes you will see probability questions tested along with sets as well. You'll have to calculate probabilities using Venn diagrams. So in a case like that, if you have, for instance, probability of a set A equal to 2/3, and then they ask you for the probability of A complement, that means everything outside of A, you can just do that calculation by subtracting that first number from 1 like that, and you will get the result. Okay, so the total probability is 1. You can use that sometimes to calculate probabilities like this. Okay, now let's make it slightly more complicated. So we were rolling a fair dice here. Now let's say you roll 2 fair dice. Now what we do is we roll 2 fair dice. Now, when you roll these 2 fair dice, we want to find the probability. Find the probability that the sum of the two numbers you get is more than 9. So you're rolling two fair dice. We want to find the probability that the sum of the two numbers you get is more than 9. Now, how do we think about this? Let's take an example. You toss one coin. You roll one dice. You could have 1, 2, 3, 4, 5, 6. You roll another dice. You would have 1, 2, 3, 4, 5, 6. How would the sum be greater than 9? One example of that could be that on one dice you get 5, on the other dice you get 6, right? And then on one dice you get 6, on the other dice you get 5, for instance. Or you could get 5 and 5, and so on, right? So these are outcomes in which the sum is greater than 9. Now, one idea is to list down all the possible outcomes like this, in which the sum is greater than 9, and then count them, divide them by the total number of possible outcomes. That's one idea that you could use. We could try that. That's one possibility. Sometimes what we do is we use a diagram for this to make things easier to understand and easier to calculate probabilities from, because you often get multiple parts of the same question in which they will be asking you for multiple probabilities of, let's say, for example, the sum being between 6 and 8, the sum being less than 3. So they might be asking you multiple questions based on this one single problem. There's a diagram that we can use in this case to make this calculation easier, and that diagram is known as the possibility diagram. That's what you can use in this case, and that would help you find out this probability and any other similar probability that they might ask you in a later part after this. Now, what does a possibility diagram look like? It's basically a 2D table, something like a 2D table in which on one axis you have outcomes from one dice written in this case, for example, 1, 2, 3, 4, 5, 6. And then vertically, you have outcomes from the other dice that written 1, 2, 3, 4, 5, 6. In this case, since we're talking about sum of the two numbers, we could have a plus sign here that represents that we have to calculate the sum of these numbers. So we can call this an addition table. The values in this table here, they are going to represent the sum of the two numbers in that row and column. For instance, if you're talking about this value, this will be the sum of the number 2 and the number 3, the numbers corresponding to that row and that column, right? So this number should be 5 here. Similarly, if I have this number here, or let's say this number here, this is going to be 6 plus 5, and that will be 11. So I can fill out this table like this, and then using this table, I can answer any question like this, where they ask us for the sum of the two numbers being greater than 9, less than something, between something. We can answer all of those questions using this one single table. So how will we fill out this table? Let's start with the first row. 1 plus 1. What's that? That is 2. 1 plus 2 is 3. 1 plus 3 is 4, and so on. 5, 6, 7. Similarly, you can fill out the rest of the table like this. It looks like this, right? This is the table that we have. Now, what were they asking about? They're asking about the probability of getting the sum of the two numbers that is greater than 9. Sum should be greater than 9. Now, we have listed down all the possible sums here. When is the sum greater than 9? These are the possible outcomes at the bottom right. How many outcomes are these? These are 6 outcomes in total, right? 6 outcomes in total. So the number of favorable outcomes, therefore, is 6. What's the total number of possible outcomes? You can count them. There are 6 columns, 6 rows. So 6 times 6, that's 36 in total. All of these values here, these are 36 values in total. So what is the probability going to be? The probability turns out to be 6 out of 36 favorable outcomes are 6, divided by the total number of possible outcomes, that's 36. And that's going to give you the result, which is 1 out of 6. And that's your final answer. Okay. So sometimes you would have to use the possibility diagram like this to help you in finding probabilities like this. Okay. This is one representation that you would often have to use. Let's take a quick example on this. Let me see if I can find a relatively more complicated one, which we have to fill out something. Yeah, okay. So now this is a slightly different version of that possibility diagram. So in the example that we saw, we were adding numbers, right? But now we have this person who spins 2 fair spinners, each numbered 1 to 4. So now we have 2 spinners that this person is spinning. They're fair. That means each outcome 1 to 4 has equal probability. Her score is the value when the numbers on the 2 spinners are multiplied together. So score is calculated by multiplying the numbers that you're getting. Now this table shows some of her possible scores. So she spins the first spinner that has these possible outcomes 1, 2, 3, 4. She spins the second spinner that has these possible outcomes 1, 2, 3, 4. First of all, we need to complete the table of possible scores. Now, how are you calculating the score? By multiplying the 2 numbers, right? So for instance, why do we have 4 here? Because this is the product of 2 and 2. Let's complete this table like this. 3 times 2, that's going to be 6. And then 4 times 2, that is 8. And so on. The next one is going to be 3 times 1, 3. And then 6, 9, 12. 4 times 2, 8. 4 times 3, 12. And 4 times 4, 16. Right? So this is a multiplication table now. The example that we saw before, that was an addition table. Now this is a multiplication table. Now it says find the probability that her score is less than 4. Now you can see how many possible outcomes are there in this table. There are 16 possible outcomes, right? 4 times 4, that's 16 possible outcomes. How many of them are favorable outcomes? The outcomes that satisfy the given condition. What's the condition? That the score is less than 4. Where is the score less than 4? These are all the possible outcomes where the score is less than 4. You can count them. 1, 2, 3, 4, 5. There are 5 possible outcomes where the score is less than 4, divided by the total number of possible outcomes, which is 16. So the probability is going to be 5 over 16. Okay. Then it says find the probability that her score is an even number. Give your answer as a fraction in its lowest terms. Again, we have that table already made. We can use that now to count the number of even scores in this. Okay, even scores. 2, 4. So let me actually count like this. 1, 2, 3, 4, 5, 6. In fact, it'll be easier to do it like this. The product is even when at least one of the numbers that you're multiplying is even, right? So when 2 is multiplied by anything, all of these numbers, they're even. When 4 is multiplied by anything, all of these numbers are even. When this 2 is multiplied by anything, these numbers are also going to be even, and these numbers are also going to be. So everything inside this green part is basically even, or to make it easier to read, everything here and everything here. These are even numbers. How many are these? These are 12 numbers in total. The total was 16. Out of them, 12 are even. So what can we say? It's going to be 12 out of 16. We have to give our answer as a fraction in its lowest terms. This simplifies to 3 over 4, and that's going to be your final result. 3 out of 4. That's the probability of getting an even score. Okay. All right. Now it says find the so this other person says that her score is more likely to be a square number than a factor of 6. Okay, now that's something that you'll need to think about a little. Is she correct? Show your working. So what are the two things that they're talking about? They're saying the score is more likely to be a square number than a factor of 6. All right. What's the probability of getting a square number and what's the probability of getting a factor of 6? We would have to find both of these probabilities, right? We have to show our working. So we have to find both of these probabilities. Probability that you get a square number. Let's figure this out. Okay, now how many of these numbers are square numbers, perfect squares? 1 is a perfect square, 4 is a perfect square. You've got 4, 4, 4 here. Then 9 is a perfect square, right? 3 squared is 9. You've got 1/9 here. And then 16 is a perfect square, that is here. 1, 4, 9, and 16. We have encircled all of those possible numbers here. How many are these? These are 6 in total, right? 1, 2, 3, 4, 5, 6 out of 16. So probability of getting a square number is therefore 6 out of 16. Let's keep it in unsimplified form because it will help with the comparison with the probability of getting a factor of 6. Okay, did we calculate that probability before? No, we did not. Probability of getting a factor of 6. What are factors of 6? 1, 2, 3, and 6. These are the factors of 6. Let's count these numbers in that table. 1, 2, 3, and 6. Okay, so where do we have 1, 2, 3, and 6? 1, 2, 3, and 6. Right? The rest of the numbers are not factors of 6. How many are these numbers? 1, 2, 3, 4, 5, 6, 7. So these are 7 numbers in total, which are factors of 6. Let's write this down there. Probability of getting a factor of 6, that is 7 out of 16. What does that mean? This probability is more and this probability is less. So probability of getting a square number is less than the probability of getting a factor of 6. What are they saying? The score is more likely to be a square number than a factor of 6. This is incorrect. Okay, so you can say she is not correct. Right, because they're saying the square number has more probability, and that's not the case when we actually can find those probabilities. Okay, I hope that makes sense. So that's how the possibility diagram is going to be used. That's one representation that you will use in probability to calculate probabilities like this. Then there's another thing that you will be using to do probability calculations, and that's called tree diagrams. Okay, that's another representation that you would have to use for probability calculations. Now, in most cases, they will give you the tree diagram themselves. Okay, so you'll have the tree diagram given there. And then using that, you would have to do some calculation. However, you should still be able to find, you should be able to draw tree diagrams yourself as well in simple cases and have a look at an example on that. But for now, first of all, let's look at what tree diagrams look like. And we'll do that with the help of this example. So you can represent probabilities on tree diagrams as well. Now, how is this going to look like? Let's look at this example. So we have a bag that contains R red beads and B blue beads. 2 beads are chosen at random without replacement. Now, this is an important thing to note as well. We'll talk about this. 2 beads are chosen at random without replacement. The tree diagram shows the possible outcomes and their probabilities. In fact, what I'll do is so let's actually come back to this example after a relatively simpler example first. which will help you understand the tree diagram, and then we'll understand that without replacement thing as well. So let's say we have two containers like this. Let's look at it this way first, or just one container. So let's say I have one container, and in this container I have, let's say, 8 red balls and 4 blue balls. Okay, so this is a container in which I have 4 blue balls and 8 red balls. And what I'm doing is I'm taking out 2 balls from this container. 2 balls, or let me write it like this. 1 ball is taken from the container. It's taken out of the container. And put back in it. Then another ball is taken out of the container. So we have this container that has 8 red balls and 4 blue balls. What you're doing is you take 1 ball out of this container and you put that back in the container. Then you take another ball out of the container. So you're taking out 2 balls from the container, but once you pick up the first ball, you put that back inside, and then you pick up another ball after that. We want to find the probability. Use a tree diagram to find the probability that the 2 balls taken out have different colors. They have different colors. So the first time you take out the ball, that's one color, and then the second time when you take out a ball, that's the second color. They should have different colors. We have to use a tree diagram to figure out this probability. Okay, so let me read out the question statement again. 1 ball is taken out of the container and put back in it. Then another ball is taken out of the container. Use a tree diagram to find the probability that the 2 balls taken out have different colors. Now, first of all, let's make a tree diagram for this. Now, what does a tree diagram look like? It's basically a structure that represents the possible outcomes that you can get from a particular situation in the form of something that looks like a tree like this, that you have lines representing the different outcomes that you can get in each step. So the first time when you take out a ball, there are 2 possibilities. One possibility is that the ball is red, and the other possibility is that the ball is blue. So these are the 2 possible outcomes when you take out 1 ball the first time. You can either get a red ball or a blue ball. These lines that we have, these are called branches of the tree. You have probabilities written on these branches. So what's the probability of getting a red ball when you take that out? The probability of getting a red ball is 8 out of 12. There are 8 red balls. Out of how many? Out of 12 balls. What about the probability of getting a blue ball the first time? You have 4 blue balls. Out of how many? Out of 12. We often write probabilities on a tree diagram in unsimplified form that helps with our calculation. It's okay to simplify it as well, but it's allowed to leave it in unsimplified form like this as well. This will make your calculations easier if you leave it unsimplified like this. So let's say I have a situation like this, in which the first time there are 2 possible outcomes, red or blue. I can represent those 2 possible outcomes in the form of a tree like this. that there are two outcomes, red or blue, and each of them have these probabilities. Okay, now that's just for the first ball. Okay. Once you take out the first ball, you put that back in the bag, back in the container, and then you take out another ball. If you had taken out a red ball the first time, the next time again, you have two possibilities. You can take a red ball out, or you can take a blue ball out. If you had taken out a blue ball the first time, the second time you again have two possibilities. You could have a red ball, or you could have a blue ball. Now, what's the probability of getting a red ball again? 8 out of 12. Probability of getting a blue ball again, that is 4 out of 12. Red ball, 8 out of 12. And blue ball, 4 out of 12. Okay, these are the probabilities that we get from this. This is the tree diagram that we get from this. Okay. Now, this is an example that we call a case that is done with replacement. This is probability with replacement. What does that mean? When you take out a ball, before taking out the second ball, you are placing the first ball back in the container. So the second time you take out the ball, the probabilities of taking out a red ball and the probability of taking out a blue ball, they remain unchanged. They are not changing. This is called probability with replacement. Replacement means that you're replacing that ball back before taking out another ball. So this is with replacement. The probabilities of red, they remain unchanged. The probabilities of blue, they remain unchanged from the first time you're taking out the ball to the second time that you're taking out the ball. Okay. Now, from this tree diagram, if you had to do some calculations, like what's the probability that the first ball was blue and the second ball was red? What is this probability? How do you calculate this? You look at the tree diagram and see where is this condition being met. First should be blue. That means that's this path that you have to follow on the tree diagram. The first has to be blue. And then the second should be red. So the second ball should be red. These are the probabilities that we have in each of these cases. 4 out of 12, 8 out of 12. What we do is we multiply these two numbers, 4 out of 12 times 8 out of 12. You can put this on your calculator, and this will simplify to 1 over 3 times 2 over 3, which is 2 over 9. That's the probability of getting the first ball blue and then the second ball red, if you had to calculate that, right? We'll come to this, this probability that they're asking about. But let's do these simpler calculations first. If you had to find the probability that the first ball is blue and the second is red, this is what it would look like. Okay. You multiply these probabilities along the branches. You multiply 4 out of 12 and 8 out of 12 like this. Then if you had to find the probability that both balls are blue, what would that be? You look at the tree diagram again. What is the path that we have to follow in this case? The first should be red and the second should, the first should be blue and the second should be blue. Both have to be blue. That means that is this path, blue and then blue. What is this probability going to be? The first is 4 out of 12. You multiply that with 4 out of 12. 4 out of 12 times 4 out of 12, that will give you 1 out of 9. That's the probability of getting both blue balls. Okay. Now, what if you had to find the probability that the two balls taken out have different colors? Both of them have different colors. How do you find this probability now? How can you have different colors when one is red and the other is blue? Okay. Now look at the tree diagram. What possibilities are there such that the balls would have different colors? One possible outcome is that the first time you take out a ball that is red, the second time you take out a ball that is blue. Or you could also have this case that the first time you take out a ball that is blue and the second time you take out a ball that is red. These are the two possible paths that you can follow on the tree diagram such that you have two different colors. Okay. Now, how do you find this total probability then? Now, this is important to understand. This is the most important thing about tree diagrams. When you go along the branches like this, horizontally along branches, you multiply probabilities. So you multiply 8 over 12 with 4 over 12 in this case, for instance. If you do that here, you get 8 out of 12 divided by 4 out of 12, and that will give you something. In this case, that would be 2 out of 9, right? And then if you had to find the probability of the first being blue and the second being red, again, you multiply these numbers, 4 out of 12 and 8 out of 12. What does that give you? That also gives you 2 out of 9. So when you go along branches horizontally, what do you do with probabilities? You multiply them because there's an and between them. You're taking out a red ball the first time and you're taking out a blue ball the second time. And in the second case, you're taking out a blue ball the first time and you're taking a red ball the second time. There's an and between these cases. When there's an and between cases, we multiply probabilities. So along the branches, we will be multiplying probabilities. But then we have two different cases. It's either the first case here or the second case here. These two cases, we are going to add together. So we will add these two cases together, 2 over 9 plus 2 over 9, and that gives us 4 out of 9. That's the total probability that we get. Vertically, there is an or between cases. So you could either have the first case, right, that the first is red and the second is blue, or you could have the second case where the first is blue and the second is red. Vertically, in a tree diagram, there's an or between cases, right? That it's either this case or this case or this case. In that case, you have to add probabilities. So on a tree diagram, when you go horizontally, you multiply probabilities. When you go vertically, you add probabilities. Okay, let me write that down here because this is going to be very important now when you use tree diagrams. Vertically, or let's start with horizontally, or along the branches in tree diagrams, what you do is multiply probabilities. Why do you do this? Because there's an and between the cases, right? The first thing has to happen and the second thing has to happen and maybe another thing has to happen. There's an and between cases, so we multiply probabilities. Vertically on a tree diagram, we have one case, we have another case, we have another case. There's an or between cases that it's either this case or this case or this case. When that is the case, you have to add probabilities. Okay? Some probabilities, you add them together. Okay? So this is something that you need to keep in mind when you have a tree diagram and you have to use that for some calculations. Along branches, you multiply probabilities. Vertically, you add probabilities. Now, this was the case when you were doing something with replacement. You were taking something out, putting it back, and then taking another thing out. You saw that the probabilities here remained unchanged. Now, a slightly different version of this is also possible that we saw in that other example that I showed you earlier. Let's have a look at this now. There's this bag that contains R red beads. So we have R red beads and B blue beads. Two beads are chosen at random without replacement. The tree diagram shows the possible outcomes and their probabilities. Okay. Now, the first bead, they're saying the probability of it being red is 3 out of 5. The probability of it being blue is 2 out of 5. The second time what happens is this number is changing. The probability of the red bead is something else now. The probability of blue bead is something else now. It's not the same as before. It was 3 out of 5 earlier. Now it's 11 out of 19. I'll make it simpler for you just so we use this example to understand without replacement possibility. These probabilities are actually going to be in unsimplified form. They would be 12 out of 20, the first one. And this is going to be 8 out of 20. So what's happening is there are 20 beads in total. So there are 12 red beads and there are 8 blue beads. So 20 in total. So there are 20 beads that we have in total in a bag. The first time you take out a bead, what's the probability of getting a red bead? There are 12 in total out of 20. That probability is 12 out of 20. The second time you take out a bead, the probability of getting a red bead is going to be less now. Why? Because you've taken out a red bead already. The total number of red beads was 12 earlier. Since you've taken one out already, now you have 11 left. So the probability of getting another red is going to be less than before. It will just be 11 in the numerator. What about the denominator? You had 20 in total since you've taken one out already. The second time, the denominator would be one less than 20, which is 19 now. So the probability that the second bead is also red is 11 out of 19. So this is without replacement. That you're taking out a bead, and then before you take out the second bead, you're not putting the first one back. Okay, this is without replacement. Generally, when they do not specify anything, you assume that this is without replacement. And that's the case that you would mostly see, that it would be without replacement. If it is with replacement, they will always specify that. Okay. If it's with replacement, they'll always explain it like this, or they would say with replacement. They will always specify that. Let me write that down here as well. With replacement will always be specified. They will tell you clearly in the question that this is with replacement. Without replacement, if they don't say anything, assume that it is without replacement. You're not putting the first object back before taking out the next one. Okay. So if it's not specified, you assume that this is without replacement. All right. In this case, they have specified clearly that this is without replacement. Whenever this happens, you will see that the denominator, the next time, is going to be one less than the first time. Why? Because the total number is always going to reduce by one. So the denominator and the second time is always going to be one less than the first time. So they're all 19 here now, the second time. Now let's understand how we calculate how do you figure out the rest of the probabilities. So if the first time the probability of taking out a red ball was 12 out of 20, if you take out a red ball, the next time this probability reduces to 11 out of 19. What about the probability of getting a blue ball? There are still 8 blue balls in the container. So the numerator is still 8, but the total number is reduced to 19. The denominator is 19. So this is 8 out of 19. Another way to think about this could be in a tree diagram, probabilities coming out from a single point, they always add up to 1. So if this is 11 out of 19, the other probability would be 1 minus this, which is 8 out of 19. In the second case now, if you were to take out a blue ball the first time, what does that mean? The number of blue balls now reduces from 8 to 7. The number of red balls is still the same. So when you take out a blue ball, when you've taken out a blue ball, how many balls are you left with? You have 12 red balls now and 7 blue balls. So what's the probability of taking out a red ball the second time? It's 12 out of 19. A blue ball the second time, that is 7 out of 19. And in the previous case, we had 11 red balls left and 8 blue balls left once we took out a red ball the first time. So probabilities the second time changed according to that. All right. This is what happens when you have to calculate probabilities without replacement. The tree diagram would look something like this. Now, using this, we need to find the probability that both beads are red. How can we do that? Red and red. Just multiply these two probabilities, 12 out of 19, 11 out of 19, and that should give you the result. 12 over 19 times, 12 over 20 times 11 over 19, and you can see what that is. That will give you the result. Okay, you can do this calculation and see what that is. Okay. Calculate the probability that the two beads are different colors. Now, what does that mean? Red, blue, that is one possibility. Or blue, red, that's another possibility. You find each of these cases. So you say 12 out of 19, 12 out of 20. Why am I writing 19 again and again? 12 out of 20 times 8 out of 19. That's the first case. And the second case, 8 out of 12 times 12 out of 19. What would that be? 8 out of 20 times 12 out of 19. You calculate each of these probabilities and then add them up together. And that will give you the final result here. Okay. I hope that makes sense. This is how we do these calculations. Okay, we'll have a look at the relatively more complicated examples on this the next time. For example, the third part of this where we have to calculate the value of R. I did that for you in this case, but we'll look at this again the next time. For now, we were just trying to understand how the without replacement thing works. Let's take another example in this to understand this better. Okay, let's have a look at this now. This is another example. So now we have 3 things happening. A bag contained 5 red and 2 blue beads. Okay. Chris took 3 beads at random and without replacement. So when he takes out 1 bead, he's not putting that back before taking out another. The probability tree shows the possible outcomes and their probability. So you have this tree diagram made here. Okay. Now, since he's taking out 3 beads, there are 3 steps in this tree diagram. This is for the first bead, then the second bead, and then the third bead. Right? So it's a big tree diagram like this. Let's try to understand how these probabilities are calculated. The first time, the probability of getting a red is 5 out of 7 because there were 5 red. But then when you take out a red ball, how many balls are you left with? You have 4 red and 2 blue. So you see, the probability the next time they reflect that 4 out of 6 and 2 out of 6. If, for instance, you take out another red ball, what are you left with after that? 3 red balls and 2 blue balls. What's the probability of red after that? 3 out of 5 and 2 out of 5, right? So without replacement, this is what happens to probabilities. The denominator keeps reducing, right? And the numerator also changes sometimes based on what you did the previous time. Let's have a look at what they're asking for now. Write down the values of P, Q, and R. Now, they've omitted these probabilities and they want you to calculate these yourself. Now, how can we calculate these probabilities? Let's think about this. Initially, we had 5 red and 2 blue balls, right? If you take out a blue ball the first time, what are we left with? We are left with 5 red balls and 1 blue ball. Okay. Then the probability of getting a red ball is 5 out of 6, blue ball 1 out of 6. If you take out a red ball after that, what are you left with? 4 red balls and 1 blue ball. So this is the situation. Okay. So the probability of blue, therefore, is just going to be 1 out of 5. So P is going to be 1 out of 5. Okay. Or a quicker way and a direct way of calculating P could just be that from this one branch, from this one point, you have 2 branches coming out. One has the probability of 4 out of 5. The other has to be 1 minus that because the total has to be 1. So you can also say P is going to be 1 minus 4 out of 5, which is 1 out of 5. That could be another way of thinking about this. But now for Q and R, we don't have any probabilities given on these 2 branches. So for this, we have to do all of that working to try to understand what is happening at each step. So when we took out a blue ball here, we were left with 5 red and 1 blue. Now, if we take out another blue ball here, what are we left with? We only have 5 red balls and there is no blue ball left. What does that mean? Probability of getting a blue ball is just 0 out of 5. That's just 0. So R is going to be 0 for that reason. If this is 0, the sum has to be 1. So Q has to be 1 for that reason. Or you can also say it's 5 over 5, which is 1. So Q is equal to 1 and R is equal to 0. Okay. Now it says, expressing each answer as a fraction and in its lowest terms, find the probability that 3 red beads were taken. Now you just have to use this tree diagram, find out what path to follow. 3 red means this, this, this. Just multiply those probabilities. It's 5 out of 7 times 4 out of 6 times 3 out of 5. You can put this whole thing on your calculator directly and you should get your result from that. You can see what that is. 12 out of 42. Right? Yeah, 12 out of 42, 6 out of 21. And that can further be written as 2 out of 7. So this should be 2 over 7. Okay, that's 2A. Then they're saying the first bead was red, the second blue, and 3 red. Again, just have to follow that path on the diagram. First blue, the first red, second blue, and then third red. That's the path that you have to follow now. Just multiply probabilities along those branches. 5 out of 7 times 2 out of 6 times 4 out of 5. And you'll get that probability. Again, you can see what that is. It's going to be 8 out of 42, which is 4 out of 21. And that's it. So this is 4 out of 21 for 2B. And then finally, you could do the third part is 𝗣𝗽𝗀𝗿. What does that say? 2 of the beads are red and 1 was blue. Okay, 2 were red and 1 was blue. Now that requires some thinking. 2 red and 1 blue. What possible outcomes can we have? What possible paths can we follow on this diagram? Red, red, blue. We have 2 red and 1 blue. But is that the only possibility for getting 2 reds? There are other possibilities as well, because we could have red, blue, and then red, right? That is also 2 reds and 1 blue. Or we could also have blue and then red and then red. So there are 3 possible paths that we can follow on that tree diagram to get 2 reds and 1 blue. Now let's figure out these probabilities. The first is going to be 5 out of 7 times 4 out of 6 times 2 out of 5. What is this going to be? 8 out of 42, which is 4 out of 21. Okay, then the second one, red, blue, red, we already calculated that probability here. That was also 4 out of 21. And then the last one, 2 out of 7 times 5 out of 6 times 4 out of 5. You can calculate this as well now. 2 over 7, 5 over 6, and 4 over 5. This also turns out to be 4 out of 21. So you have this case, and this case. You add all of them up. 4 out of 21 plus 4 over 21 plus 4 over 21, and you'll get a result. That is 12 over 21, which simplifies to 4 over 7. And that is the final result that you get from this. Okay, so this is how we do calculations based on tree diagrams when you have with replacement or without replacement. Now, another thing that we found here that you need to note is that on a tree diagram, probabilities coming from a single point they always add up to 1. Sum of probabilities coming out from a single point that is always equal to 1. You have to keep that in mind. So if you have one of those probabilities known and the other is unknown, if they're just 2 branches, you can find the other by subtracting from 1 like this. Okay, so this is how probability works. We will look at some more difficult questions in the next class, along with discussing conditional probability, which is part of the IGCSE syllabus. It's not the part of O-level syllabus. In terms of, as far as O-level syllabus is concerned, this is all the concepts that you need to know of. We will look at some more examples in the next class, inshallah. But for IGCSE, you also need to know conditional probability, which we will do in the next class as well. Okay, so for today, this is it. If you have any quick questions, you can let me know. Otherwise, we end this here. Any problems in this? No? Okay, all right. So I'll see you again in the next session. Allah Hafiz.